Well, ladies and gentlemen, I hope you're ready to tackle some inverse functions because we got a pretty special topic tonight, and one that you'll see reappear throughout not only this course, but I think all your future math courses. So to get things started, I got a fun picture for you to look at, and I want you to think of function f as being a magic box or a magic factory that converts apples into lemons. In other words, apples are the input, and then it produces lemons as the output. Then the inverse of function f then takes those lemons and converts them back into apples. In other words, the inverse of f basically undoes or does the opposite of whatever function f did. In other words, whatever you started with, you're guaranteed to end up with the exact same thing. Okay, our first definition here says if a function y equals f of x has an inverse that is also a function, we represent it as f with a little -1 of x. Be very, very careful. This is not technically an exponent. It's just a special notation for denoting an inverse. And how is it pronounced? It is pronounced f inverse of x. Bingo. Okay. Now maybe the most important thing we say all night is that f of x and f inverse of x undo each other, okay? In other words, whatever operations were performed by f of x, f inverse of x is then going to do the opposite or undo all of those operations. So for instance, if we look at our first composition here, where it says f inverse of f of 2, we talked about compositions last week, and we said, well, we're going to take the 2 and we're going to substitute it into function f, and then whatever the output happens to be, we're going to substitute that into f inverse. Okay. Now, just like the last picture, we talked about apples became lemons, and but then they became apples again. The final answer here is just going to be a 2, and I don't even know what equation f or f inverse are. I just know that I'm always going to end up with whatever I started with. Example number 2, if I start with a 6, I know I've got to end with a 6, and it's as simple as that. Okay, for the next few minutes, we're going to focus on how to find an inverse graphically, and then about halfway through the video, we're going to switch and we'll talk about how to find an inverse function algebraically, and we're going to be really, really good at both of those methods. Here it is. It's as simple as switch, or you can say we're gonna switch x and y. It's as simple as that. So for instance, let's take a look at this. We're going to say there's a point called 3, 5 that lies on the graph of f of x. Then what do we know for sure? There's a point 5, 3 that lies on f inverse of x. How about that? Notice what I did is I took what used to be x and what used to be y, and I switched them, and they became 5, 3. Notice, now here's a good thing to point out. I didn't negate the 3, I didn't negate the 5, I just switched them. Alright, let's take a look at the next example here. If the point -2, 8 lies on a mysterious function called f of x, then what do we know must be true? We know that 8, -2 must lie on the graph of f inverse of x. Okay? Let's see if we can generalize that now. If you know that there's a random point called a, b and it lies on f of x, then what must be true? There's a point called b, a that must lie on f inverse of x. So we're starting to definitely see a pattern here for sure. Let's see if we can talk about the same thing but use a little different notation. Okay? When I say that f of 3 equals 4, what I'm really trying to say is that there's a point 3, 4 that lies on f of x. Then what must be true? Well, let's see. Let me erase that. What must be true? We're going to say f inverse of 4 must equal 3. Now notice what used to be the x value is now the y value, and what used to be the y value is now the x value. And again, all we're saying here is that there's a mysterious point 4, 3 that lies on f inverse of x. Okay, let's try another one. Alright, if you know that f of -9 equals 2, then what do you know now must be true? F inverse of 2 must equal -9. And to generalize that, if f of a equals b, then we know that f inverse of b must equal a, because we're going to switch the x and the y values. Alright, let's take a look at a real graph here, a real live graph. And what I'm going to do is I'm going to start at the far left, and I've got this point negative 4 comma negative 2, and the inverse of that, if I switch them, is going to become negative 2, negative 4. And let's see, negative 2, 1, 2, 3, it's going to be down here, right at the bottom edge of my screen, okay? And what I'm going to do is I'm going to label that bear A, and I'm going to label this bear here A prime to show that they're inverses of each other. The next point, negative 3 comma 0, the inverse would be 0 comma negative 3, and that would put me right here. So let's say if I call that B, this would be B inverse. Let's call this bear C, and the inverse of negative 1 comma 1 would be positive 1 negative 1, and I'll call that C prime. Let's call this point D, and the inverse of 0, 3 would be 3, 0. We'll call that D prime. And the last one here, we'll call this point E, and the inverse of 4, 4 is, well, by golly, it's just 4, 4. So E and E prime are one and the same, and I'm going to connect them very carefully. Bada bing, bada boom. Yeah, yeah, yeah. Yep, we're looking good. Now we're going to talk about drawing some conclusions from this great picture we just made, and unfortunately I couldn't fit the graph on the screen at the same time, but hopefully you've drawn a really good picture in your notebook and you can look at it as we talk. And we want to talk about what is the domain of f, and it's a really good review from last week, and I'm going to say, based on looking at my picture, my x min is negative 4 and my x max is positive 4 with closed brackets because of the closed circles. In my range, I'm going to say, again, I'm looking at the original f, the y min was negative 2 and the y max was positive 4. Now if I switch gears and I start to look at the red graph, or my f inverse graph, my domain, my x min was now negative 2 and my x max was 4. My y min was negative 4 and my y max was positive 4. Now what you'll notice here, and this is extremely valuable, is that the domain of f of x is the same as the range of f inverse. And vice versa, the range of f of x is the same as the domain of f inverse, and that'll be true for all functions. Well, before we go any further with the graphs, I want you to check out the special relationship between the two graphs. And when I say the two graphs, I'm referring to the original function called f of x and his inverse that we call f inverse of x. And there seems to be a special reflection there, or mirror image, that's taking place here. And there actually is, if you draw a diagonal line that starts at the origin and it passes through the point 1, 1, 2, 2, 3, 3, 4, 4, etc. That beautiful diagonal line, first of all, the equation of this diagonal line is called y equals x, very special linear function. And we would say that f and f inverse are mirror images or reflections of each other over the line y equals x. So what we want to do is we want to try to generalize that and put this special relationship in our notebooks here. So let's take a moment here to write that down. So just like we said, f of x and f inverse of x are reflections or mirror images of each other across the line y equals x, and that's a real special detail that we'll definitely be looking for in our notebooks to make sure we've got great notes tomorrow. Here's one more graph to practice on. We're going to say that they have given us a picture of f of x right here, this bluer graph, and we're going to try to sketch f prime, and I think this would be a real good one to try on our own. I would say, first of all, copy down f of x as best you can, and paying attention to the y-intercept, the x-intercept, and a few other special points it passes through, and then go ahead, hit the pause button, and try to graph it and see if we came up with the same thing. Okay, the first thing that I noticed was there was this really nice point here at 0, 1, whose inverse is 1, 0. There's another point here at 1, 3, whose inverse is 3, 1. And let's see, there's a point here, negative 1, negative 1, who, ironically, just happens to be its own inverse. And then there's another point, negative 2, negative 3, whose inverse is negative 3, negative 2. And I'm just going to try to connect those dots as carefully as I can. Notice I did extend all the way through the two extreme edges of the graph paper, and I'm going to label that as f inverse of x. A couple other conclusions here we want to make a note of. Looking at the picture you just drew, who is the x-intercept of f of x? And hopefully you would say x equals approximately negative 1/2. And the y-intercept of f of x was y equals 1. Now look at the red graph that I drew. The x-intercept is now x equals positive 1, and the y-intercept is y equals negative 1/2. And so what you'll see is the x-intercept of f of x is the exact same as the y-intercept for f inverse, and vice versa. The y-intercept of f of x is the exact same as the x-intercept for f inverse. Okay, this next exercise is going to be really, really simple, but it's a good one to practice just so we're all on the same page. They've given us a table of values. So instead of giving us a graph, they're just giving us a table of values for f of x right here. And we've got a point 0, -6, 1, 2, 2, 3, 3, 8, 4, -10. And they want me to fill in this table for f inverse, and here it is. If you take a look at the first point, and that's really what they're saying is 0, -6. The inverse would be -6, 0. And it all goes back to what we said earlier, is that we're going to switch the x and the y values. The next ordered pair would be 2, 1. The next one would be 3, 2. The next one would be 8, 3. And the last one, again, just switching those two values, -10, 4. Easy enough. Okay, we're going to totally switch gears now. We're going to get away from the graphical approach and focus on our algebraic approach. I think some of us will like this better, while others of us will prefer the graphical approach. I'm going to give us a little four-step game plan here, and then we'll go ahead and apply this game plan or this recipe to a few examples. First things first, replace f of x with a y if necessary, and of course these are always interchangeable. Number two, magical word today, switch. Switch the variables x and y with each other. Step 3, solve for y and express in y equals mx plus b form. And we've talked about how that's called the slope-intercept form. And then last but not least, replace that y with the appropriate notation, f inverse of x. And that's all there is to it. Alright, what I'm going to do is I'm going to follow that four-step game plan perfectly here. And the first thing it says, replace f of x with a y if necessary. And it was in this case because they did use an f of x. The next thing I'm going to do, and this is the most important step, is we're going to switch those variables. So it's now x equals 4y plus 2. Now what they want me to do is they want me to solve for this y right here and try to get the equation in slope-intercept form. So first things first, I'm going to subtract a 2 from both sides. X minus 2 equals 4y. And then what I'm going to do is I'm going to divide both sides by 4. Divide by 4, divide by 4. And as I'm cleaning up the left side, I'm going to use what we called, I think it was like on our first or second video of the year, we called it the distributive property of division. And I'm going to break this big fraction up, and I'm going to say x divided by 4 minus 2 divided by 4 equals y. And then we could simplify it. We could say this first fraction is really 1/4 times x minus 1/2 equals y. And the last thing they want me to do is to replace that y with appropriate notation. And I'm going to say f inverse of x equals 1/4 of x minus 1/2. And that will be my final answer. Okay, so here's some more practice. It's going to be slightly more challenging because there's a fraction there. We have a slope of 3/5. But again, I would encourage you to try this one by yourself. I would say step 1's not necessary because they didn't use f of x. They just came right out and said y. So now I'm going to go to step 2 and I'm going to switch those two variables. X equals 3/5 y minus 6. I'm going to add 6 to both sides and I'll get x plus 6 equals 3/5 y. Now watch how I'm going to write this. I'm going to write as 3y divided by 5. And that's equivalent to saying 3/5 y, but I like this better. At the same time, what I'm going to do is I'm going to put x plus 6 over 1. And now what you're going to see me do is I'm going to cross multiply. So first things first, x plus 6 with a 5 distributed through it. Remember, distribute the 5. We're going to get 5x plus 30. And then on the other extreme diagonal here, I'm going to get 1 times 3y, which equals 3y. Okay, now I bet you're going to feel really comfortable now. Divide both sides by 3. And then we're going to use their distributive property to say 5x divided by 3 plus 30 divided by 3 equals y. Clean it up a little bit if you want. We could say 5/3 times x plus 10 equals y. And I'm going to replace that y with my f inverse so I've got the appropriate notation. Alright, last one of the night. We'll finish strong. Certainly our most challenging question of the night. And what I'm going to do, step 1 says replace f of x with a y, but again, not necessary because they're just using a y. Step 2 says switch the variables. So I'm going to say x plus 10 equals 1/2 times the quantity y plus 7. What would you do from here? This is a great question. Now remember, we're trying to get the y by itself. One little, and again, there's multiple ways that we could approach this. Now what I'm going to do is I'm going to rewrite this right-hand side. I'm going to say the quantity y plus 7 divided by 2. And that's equivalent to what I have right here. Next thing I'm going to do is I can put x plus 10 over 1 and then cross multiply, and I'll end up with 2x plus 20 equals y plus 7. So what's going to happen, this is a really good thing for us to start with in class tomorrow, is if we were overwhelmed with one of these moves right here, maybe it was what I did with here with the right side, we could certainly talk about that, why it's legal, why they're equivalent, and we'll get some more practice in class tomorrow. Next thing I'm going to do is I'm going to subtract 7 from both sides, and let's see, 2x plus 13 equals y, and I could go ahead and replace my y with the appropriate notation, f inverse of x, and boom, we got it. It's all done. So I hope you had a great night tonight, and I'll see you tomorrow in class.